Welcome back to Algebra. We are in Chapter 6, Section 2, Radicals and Rational Exponents. Ooh, this one's going to be fun. All right, let's do a little bit of reviewing, right? 3 times 3, we can write as 3 squared, and that is 9. We call the 2, this is an exponent, okay? Now, if I want to go from the 9 back to finding one of these two factors, okay, one of these two factors is called the root. Okay, so this right here is the root. If I want to find that, since this was a square, I need to take the square root. So the square root of 9, right, is one of its two equal factors. So if I have 3 times 3, then the square root of that is 3. All right, very good. Now, if I have 3 equal factors, we can use a cube. Now, if I want to find one of those equal factors, if I want to find the root of that, since I multiplied 3 together, right, this was a cube, so I have to take a cube root, right? So I have the cube root of 27. Oh, already wrote that part, didn't I? 3 times 3 times 3. And the cube root, one of its 3 equal factors, is 3. All right, and we can keep going. There's all kinds of fun, right? If I have to the 4th power, then we can do the 4th root. All right, make sure if you have your calculator close by, pause this and see whether you can find the function, all right, the multi-root function, times 3 times 3 times 3. Since we have 4 equal factors, one of those equal factors is its 4th root. On your calculator, that function looks like this, okay, and on most of them, that is a second option to the exponent button. Right, so if you find the exponent button right above that, you should have the multi-root function. Okay, now if we keep going, then we can keep going to however many numbers we want, however many factors. So n for however many any factors, so the exponent n, then I would use n for this, the nth root of well, whatever we got here as a result, right? For that would be a. Okay, so this right here is called the index. The index, write that down. The entire expression is a radical. Okay, and this is the radicand. Radicand. Okie dokie dokie. So, there we go. There's the entire expression. Now, if you have x squared and you're taking the square root, right? If there's no index, then there's a 2 implied. Okay, so if there's no index, that's a square root. If I take a square root of a square, the square root and the square cancel out, and that is just x, right? Because x squared means x times x, and the square root is one of its 2 equal factors, so that is x. Okay, we're going to need that information a little bit later. All right, now, if I have a to the 3rd and I multiply that by a to the 3rd, then that's like a to the 3rd times a to the 3rd, which I could also write as a to the 3rd to the 2nd power, squared, a power to a power. Now, there are 6 factors here, so that's going to be a to the 6th power. How do I get that? I get that from 3 times 2. A 3 times 2, a power to a power, we would multiply those powers. So that's how I get a to the 6th. Okay, all of this was information for you to recall, so we can look at this crazy situation here. right? Here I have an exponent. That's a fraction. So rational exponent, a to a half squared. Now, remember, a power to a power, we do 1/2 times 2. Well, that gives me 2/2. If I multiply those two, and that's a to the first power, which is just a. So if I have a to a half squared, then that's just a. What other number, if I square it, do I get that base? Well, the square root. If that's squared, that also gives me the base. Knowing this information, that if I square the square root, I get the base, means that this right here must be equal to that expression. So a to the power of a half is the same as the square root of a. Now, where do we get the square? Right here, that 2. Okay, that's the index. So a to 1/n, right? There's the index. That would equal n(a). Okay. Staying with me here? All right. Here's a few different cases. If you have let's not do a. Let's do if I have -3 squared, right? In parentheses, very important. That's -3 times -3. That would be +9. Anything that I square, whether it's positive or negative, is going to end up positive. So if I find the square root of +9, that could be 3, but it could also be -3. So that's why we sometimes write it as +negative square root of 9, because I don't know. The square root of 9, did I initially have a 3 or did I initially have a -3? So there's a positive answer or a negative answer. So anytime I have an even exponent, there's going to be an equal amount of pairs of negatives, right? So if it's to the 4th power, then I have 2 pairs and the negatives are going to cancel out. If it's to the 6th power, 3 pairs, the negatives will cancel out. Now, if that was to the 3rd power, then my negatives won't cancel out. So if this is to the 3rd power, then I get another -3, and that is -27. So if n is odd, right? If my exponent is odd, or the index is odd, then I'm going to have a negative here if my initial number is negative. If it's positive, my result is going to be positive. So if n is odd, then a has 1 real root, right? Because there's only 1 root that I could have for -27. Okay, then a has 1 real root. If n is even and a is greater than 0, then it has 2 real roots. And that's positive or negative. Or I could also write positive or negative a to the 1/n, 1/n. If n is even and a is 0, then a has 1 real nth root to the square root, or whatever root of 0 is 0, because many times as you multiply 0, you always get 0. And if it's even and a is less than 0, then a has no real nth root, right? Because if I have -4, there's no square root of -4, because I can't multiply. -2 times -2 is still +4, right? There's nothing I can multiply with itself to get me a -4, except imaginary numbers, and we're not talking about those now. All right, let's look at a few examples. The index is 3. The cube root of -27. We can type that in, or we can write it out. -3 times -3 times -3. So the cube root of -27 is -3. The fourth root of 16. 16 can be written as 2 times 2 times 2 times 2. So those are 4 equal factors. Therefore, the fourth root is 2. All right, evaluate each of these. Cube root of -8. Well, that's -2 times -2 times -2. Boom. So the cube root of that is -2. We just found the cube root of 8 is 2 times 2 times 2, so the cube root of 8 is 2, this part, and there's a negative out in front. That stays, so it's still -2. Here, we can rewrite this as the fourth root of 16. We just looked at that example a moment ago. That is 2. And this right here is the fourth root of -16. Notice the index is even. There's negative, so there's no solution. All right, now here we have some craziness going on. Notice that it says 16 to the power of 3/4. 16 to the power of 3/4. Well, 4 could be the index, but why is there a 3? Well, if we go back, remember I can multiply these when we had that example of a to a half to the second power gave us a 2/2, right? So that means I could take this out, 16, and then cube root, fourth root, and take out a 3 right there. So inside there I have the fourth root of 16 to the third power. The fourth root is 2. To the third power is 8. Do the same thing here. Rewrite that, and I know that this means that's the cube root of 27 to the fourth power, and I know the cube root of 27 is 3. 3 to the fourth power is 81. All right, in this next example, they want us to find the radius of a sphere, and they've already solved the formula for the radius. Okay, but now we need to fill in. We know the volume here, and we're using 3.14. All right, so the radius is equal to 3 times, we know the volume, so 113, over 4 times, and we're using 3.14 for pi, and that is to the power of a third, which means we can convert this to the cube root, and then we can type all this into our magical calculation devices. And we get 339 over 12.56. That's approximately 3. Okay, we want to calculate the annual inflation rate, R, in decimal form of an item that increases in value P to F over a period of n years, and we can use this equation right here. We want to find the annual inflation rate to the nearest 0.1% of a house that increases in value from this to this amount over a period of 5 years. It told us from P, so this is P, to F. All right, F goes on top, so 235K goes on top. And from P, 200,000 on bottom. And over 5 years, 5 is N, so we put 5 there. And then we type that in as the fifth root of 235,000 over 200,000. That gives us the fifth root of 1.175 minus 1, and that is approximately 0.03278. And they wanted this at the nearest 10th%. So percent, move that over, we get 3 point and round that 3%.